Let's try working with scientific notation. Consider negative exponents. Remember, when the negative is in this position, it means the multiplicative opposite or reciprocal. Not a negative number as such, the reciprocal of a number. So for instance, x to the negative a is 1 over x to the a. Now, with negative exponents, there's nothing wrong with them. They're just very small generally. Consider 10 to the second is 10 times 10, isn't it? Or 100. Very simple. 10 to the third is 1,000. And 10 to the eighth, ouch, 10 to the eighth I think is 100 million. What if we looked at the negative versions of these? I shouldn't say the negative versions because they're not negative. 10 to the minus 2 is not a negative number. It's 1 over 10 to the 2th, or 1/100th, and that's how you'd write it as a decimal. 10 to the minus 3 is also not a negative number. It's 1/1000th, or 1 over 10 to the 3rd. 10 to the minus 8 is a very, very small number, 1/1,000,000th, but it is not a negative number. Do you remember using very large or very small numbers? For instance, the speed of light is a pretty large number. The distance to another galaxy is a very large number. All these occurring in science, by the way. The weight of an electron is a teeny number, a very, very small. It's not negative, but it's a very small number. The percent of students that like negative exponents, very, very small number, but it's not negative. The definition of scientific notation, the way that you would write something in scientific notation, is to write it as a number a times 10 to some number n, where a has got to be between 1 and 10, and n has got to be an integer. Recall what an integer is a signed number, a signed whole number, negative or positive or 0. Okay, well, 3.1 times 10 to the 6th is in scientific notation because 3.1 is between 1 and 10, and 6 is an integer. 3.1 times 10 to the 6th, the way you're used to seeing it, would be 3,100,000.
I don't understand.
Well, if the decimal place was here, where the 3.1 has it, it would have to move over 6 places to end up here. Hence the 10 to the 6th. Notice that a positive exponent in a scientific notation yields a relatively large number, doesn't it?
Thank you, sir. May I have another?
3.1 times 10 to the 13th would be this very large number. How do I know? Well, if I put the decimal place between the 3 and the 1 so that it's between 1 and 10, it would have to move over 13 places to get to where it really is, even though you don't see it. Remember, a decimal is always at the end of a whole number. And that's 13 places. Every time you multiply by 10, you're moving over 1 decimal place. It can't be that. While that is 13 places over, that's a very small number. And I want you to remember, don't remember lefts and rights. Remember that positive exponents yield very large numbers. Consequently, negative exponents are going to result in not negative, going to result in very small numbers. 7.9 times 10 to the minus 2 is a very small number. It's not negative. It's a very small number.
What happened?
Well, we went from 7.9, a number between 1 and 10, we went 12 digits to the left, to the small direction, and it ended up there.
There's something I have to ask you.
It can't be this one, because that's a very large number. I don't want you to remember going right and left. Recall that positive exponents will yield large numbers, and in this case,
You are correct, sir.
negative exponents will yield small numbers. That's the way to remember it.
Now I say look at here.
What if I asked you to write 3.1 times 10 to the minus 4 in standard notation? Hopefully you'd appreciate that's going to be a very small number. I'm going to take 3.1
Something's happened to my brain. It's all right.
and I'm going to go 4 places in the smaller direction, if you would. And that's why the answer is 0.00031. Because negative exponents yield small numbers.
Please come again.
So your speed of light, 186,000 miles per hour, would be 1.86 times 10 to the 5th. 1.86 is a number between 1 and 10, and 5 is an integer. Get the idea? Once again, a positive integer is yielding a very large number. We're starting with the decimal between the 1 and the 8, so we have a number between 1 and 10. And we're going over, in this case, 5 places, hence the 10 to the 5th. Get the idea?
Wait a minute.
Now, one might ask, why can't I say it's 18.6 times 10 to the 4th? Because that's 18.6 moved over 4 places, isn't it? Well, the reason it can't be 18.6 is because that number has to be between 1 and 10, and 18.6 is not between 1 and 10. You'll have to pick a value there for your A that's between 1 and 10. That way we're all writing our science numbers the same way. Get the idea? Make sure that number is between 1 and 10.
There's something I have to ask you.
Let's write the distance to another galaxy, which is 12 gagillion, I think, in scientific notation. Well, we'll have to come up with put a position of the decimal place so that the number's between 1 and 10. It's going to be 1.2, and I'm going to multiply it by 10 to the 16. Now, where did I get that 16? I counted from this position between the 1 and the 2 over to where it normally would be at the end, and that's 16 positions, I promise. That's your answer, 1.2 times 10 to the 16th. The idea is that it's saving you a lot of writing, and it's going to be very easy to compute and multiply with other numbers, actually. The weight of an electron, which is a very small number, is going to be 2.3 times 10 to the minus 14. A is a number between 1 and 10, the 2.3, and n is an integer, negative 14. See that we counted 14 places to where it ended up in its original position. And it was negative because it's a very small number. Okay? Negative exponents yield very small numbers. Go try the homework.